welcome to lecture 1.1, Defining Robots. So what is a robot? Due to the wide variety of existing robots, it can be challenging to identify the gist of this term, robot. But here are some I claim are essential. Mechanicality. A robot has a mechanical presence in an environment. Another, sensitivity. A robot can partially sense its environment. Potency. A robot can act on its environment. Intelligence. A robot can act intelligently. It's a very loaded term, of course, and we'll have to unpack that later. Artificiality. A robot is designed by humans. The footnote says that, we will also include robots that were designed by robots as long as those robots or some robot in a previous generation of robot that was designed by a human. So, artificiality. And autonomy. A robot is autonomous, acting at least partially without direct human intervention. These are necessary conditions for a device to be a robot. However, I claim they are collectively sufficient conditions. In other words, a device must have all these qualities to be a robot, and if it is missing any, it is not a robot. Although this definition of a robot may be flawed or may change in the future, it gives us a useful device for discerning if a given device is a robot or not. Furthermore, it allows us to determine which qualities the device would need to have to be considered a robot. So, this first example is it a robot? Classify each of the following as robot or not robot. If it is not a robot, list the missing qualities. Comment on ambiguities. So we have A through H, really several examples, and this will help tease out some of the ambiguities in this definition. So I thought that we could just actually take a look at this almost as a table. So I went ahead and copied these A through H up here before we started, and I want to put them next to our criteria. We have 6 different conditions that need to be met in order for it to be considered a robot on our definition. So let's go ahead and decide for each one of these if it meets these requirements or these definitions. So I'll go ahead and fill in these tables so we can see for sure what I'm discussing in each part here. All right. And the last one. There. So, I guess I'll put a line above the first one for completeness. All right, great. So, a Roomba vacuum cleaner is our first example. Let's test it for each of these qualities. Mechanicality. So, a Roomba certainly has mechanicality. A Roomba certainly has mechanicality. It also has sensitivity. A Roomba has, depending on the model, it has at least a bump sensor, which tells it when it's bumped into something. And it also frequently will have a sensor that will detect when it's near an object, so it slows down. And frequently it will also have a cliff detector. It'll have a detector to determine if it's about to go off the edge of some fall, like over the edge of a stair, for instance. So yeah, it can certainly sense its environment, so this condition is met. Potency. A robot can act on its environment. So a Roomba certainly has that ability. It sweeps up dust and whatever else happens to be on the floor in your home. So it meets that criterion as well. Intelligence. A robot can act intelligently. Now, there are certainly some models of Roomba that have a pretty advanced intelligent behavior. For instance, some of them will map out the entire home that they're in and navigate around based on this internal map that it has created. This is sort of an intelligent behavior, even though we haven't fully defined what we mean by intelligence here. That passes pretty much any intelligence test if it can have an internal map of an environment and act in it. So acting intelligently, a Roomba can certainly do that. There are some models that are more basic, and some of those, like the one that I have, does not have that ability to map out its environment. But they still manage to act intelligently based on a very simple algorithm. They don't know which part of the room, they don't know anything about a room. That abstraction is not known to the robot, the Roomba that I have. But it has an algorithm for when it detects an object, how it turns, that allows it to follow walls and otherwise to randomly move about a room. So if you leave a Roomba in, even the one that I have, in a room for a period of time, it will actually do a pretty good job of cleaning up the entire room, the floor in the entire room. So I would say yes, a Roomba acts intelligently. Artificiality. A robot is designed by humans, so a Roomba is certainly designed by humans, and it acts autonomously, at least partially without direct human intervention. And once again, a Roomba does that. It goes around and cleans up the space. So that's good, because Roombas are made by a company called iRobot, and that would be a bad misnomer if they were not robots. So the Roomba passes our test for a robot. Let's consider a desktop computer. Okay, so mechanicality has a mechanical presence in an environment. It's true that it has a mechanical presence in the environment. It's very minimal. So a desktop computer, we could say, sort of a maybe on the physical or the mechanical presence. It can't do anything to its environment, so it won't pass one of our later tests, but this is sort of a question mark there. Sensitivity. A robot can partially sense its environment, so a desktop computer. You could think of the microphone as a sensor for the computer. So it's a sort of ambiguous one. It isn't always sensing its environment when it's on. So I would say it might pass this one. We'll be generous and give it that one. Potency. A robot can act on its environment. So a personal computer can't really do that. It can present something on a screen. When we say act here, we really mean a mechanical act, and this is something that a personal computer can't do. So I would say that's a no for a desktop computer. And we can actually stop here. We don't have to continue, but we could go through and see, okay, yeah, personal computer or desktop computers do act intelligently. They are designed by humans. And they can be autonomous. You can set up a program to run. So it pretty much meets most of the requirements, but it can't act mechanically on its environment. So we wouldn't consider a desktop computer to be a robot. Of course, if it was connected up to a robot arm, then it could be part of that robot, but it is not by itself a robot. How about a home heating / cooling system? So, mechanicality. It has a mechanical presence in an environment. It certainly does. It even it's distributed throughout a house frequently. Sensitivity. It can partially sense its environment. Well, yes, the thermostat allows it to sense its environment, Potency, it can act on its environment. Well, yes, it can act on its environment. It can heat up air and blow it into a room, or it can cool down air and blow it into a room. So yeah, it can act on its environment. Intelligence, it can act intelligently. Now this is challenging. The thermostat in it allows it to be sensitive to the changes in temperature, and then it can make decisions based on the temperature. So if it's getting too cold in a room, it can turn the heat on. If it's getting too hot in a room, it can turn a cooling air conditioning on. So it's mildly intelligent. It's not overly intelligent, but it does have a little bit of an ability to react to its environment in a way that makes sense. So I would give it a sort of a weak check mark here. Artificiality, it's certainly designed by humans. And autonomous. So yeah, it doesn't need a human to say, oh, it's too hot in here, turn on the heat. A human can set it up and then allow it to act autonomously. So it pretty much passed. It was a little bit close on intelligence, but a home heating cooling system can be thought of as being a robot, which brings up the kind of the ambiguity in our definition. We have a device, home heating and cooling system, that isn't necessarily what we would like to think of as being a robot, but it does pass our checks. So maybe that's a flaw in our definition, but maybe we put up artificial dividers among different technologies. So this is a robot, this is not a robot. Perhaps part of that is more due to the way that we have thought about these devices than to do with its actual functionality. So it reveals some interesting things about how we discuss different technologies. Okay, a toilet tank. Could you come up with a less high-tech sounding device? But let's see, it's certainly a very mechanical device. Sensitivity. It can at least partially sense its environment. Well, you don't think of a toilet as being able to do that. However, there is one mechanism in a toilet that does sort of have a type of sensitivity to it. And I'm speaking specifically of the sort of tank flushing toilets. So I'll draw a little diagram here of a toilet tank, and maybe our little flusher handle there, and then we've got the toilet bowl, and inside this tank we've got water that fills up. And that water comes from usually the wall. So if we could think of it as like coming in like this, and it has a spout on it. It has a valve on it. So we'll draw in a little valve, and then it has a spout that allows it to fill up this tank. Well, as that level rises, so let's say the toilet was flushed and now the tank is refilling back up with water. As it reaches a certain level, what happens? There is a shutting off of this valve. This valve shuts off. How does it do that? How does it know when the tank is full? Well, it does that by having typically a float on top of the water that's connected mechanically to, so say like I'll put a little pin here and draw it connected to the valve. When this float is down here, I guess it would be more over here. When it's down here, it's in such a position that the valve is off. Or sorry, the valve is on. But when it's in this position, it turns the valve off. Okay, and it does that by its own buoyancy. Now, toilets have been around for a long time, flushable toilets like this, and float valves have as well. So this is actually one of the most simple examples of a control system. And a control system acts intelligently in some ways. It's very, very minimal. We might not want to say this is quite intelligence, but it really is hard to draw a hard line between what is intelligent and what is not intelligent. It doesn't overflow the toilet. The tank of the toilet, it shuts off before it does that. So there is some sensitivity there. I have to say there's some sensitivity. Potency can act on its environment. It certainly brings water in and relieves itself of water. Can act intelligently. I gotta say, so the float valve is the sensor, so that's the sensitivity. The intelligence, I would say, it's minimally intelligent. Another sort of baby check mark. And then artificiality. A robot designed by humans certainly is. Autonomous. Now, it is not really. It doesn't really quite check this box because although when it fills up, it does shut itself off, it's not going to do anything until somebody flushes it, right? So it's hard to say. The floating mechanism is autonomous, where it shuts off the valve automatically, but it's really just barely autonomous. It doesn't really function as a whole autonomously. So I would say probably doesn't quite match that one. So far to review then, we've got a Roomba, definitely a robot. A desktop computer, not a robot. A home heating system, it's kind of a robot. And a toilet tank, not a robot. It doesn't get that autonomy check from us. Okay, a car. Consider a car. Mechanicality, certainly, it's one of the quintessential mechanical devices. Sensitivity, so a lot of modern cars have sensors on them to regulate itself and even in its environment. More so more recently, but now there will be collision detection and that type of thing. So sensitivity, at least measures its own speed, that type of thing. Potency, it can act on its environment, sometimes violently so, in the case of a car. And intelligence, it can act intelligently. Well, this is really only true of a self-driving car, I would say. It doesn't do a lot. If you have the cruise control, for instance, cruise control feature, that would be a sort of intelligent act. This one sort of depends on the car. If it's an older car, probably no. If it's a newer car, potentially, yes. So especially if it's autonomous, if it's a self-driving car. Artificiality, as designed by humans, does check that one. And autonomy. So this is the without direct human intervention question. Self-driving cars are going to check this. Non-self-driving cars, probably not. There are aspects, though, of a car with cruise control, for instance, that do act autonomously. It will increase the acceleration when the speed drops too low. It will decrease it when the speed is too high. So this one is sort of marginal. Its entire function as a vehicle, though, to move us around, is not really met autonomously unless it's a self-driving car. So I would say this one is a question mark. In some cases, yes. In other cases, no. A cell phone, okay, has a mechanical presence. It's marginal here. It's just a brick that sits there for the most part. Sensitivity, there are usually accelerometers on a cell phone. Potency, can it act on its environment? Not really. Okay, a cell phone, it can make noise, which is a very minimal act, but it's a very minimal mechanical act. It doesn't really do any mechanical work, and so I would say probably no for the cell phone here. It can certainly act intelligently. It's designed by humans. Autonomous, yeah, it can do all kinds of things without our intervention. So it's close, but it doesn't quite meet that requirement of potency. Okay, a simulation of a robot. All right, now we're getting philosophical here. So mechanicality doesn't meet. It's not mechanical. It doesn't have any real existence in the world. It's a simulation in a computer, right? It is sensitive. It does have potency inside the simulation. So on the real world, on reality, probably not. Intelligence, certainly. Artificiality, certainly. Autonomy, certainly. It's missing that mechanicality and ability to act on its environment. Okay? A 3D printer. Okay, mechanicality. Oh yeah, 3D printer has got mechanicality to it. Sensitivity, yeah. So there are usually sensors in the heating filament, in the position of the tracks to move the head around. So yeah, sensors. Potency. Oh, it can certainly act on its environment. It can take hardened plastic, solid plastic, and turn it into a different shape by heating it up and moving around. So yeah, it can certainly act on its environment. Acts intelligently, yeah. I mean, it reacts to sensor values to do something. It's minimally so. I would say that the 3D printer intelligence it's kind of marginal. It doesn't react to, like, if you've ever used a 3D printer and had something go wrong, it isn't always good at catching that. So I would say, maybe a half check mark, minimal check mark there. Artificiality, certainly artificial, and autonomy. Yeah, it is pretty autonomous. So you just tell it to print this piece, you give it the instruction, and it will go about and do it without your intervention. You don't have to tell the head where to go. It will do that. So yeah, it's pretty much a robot. Intelligence level is kind of lacking. This is kind of the one that tends to be ambiguous, right? Intelligence is hard to define, and also it's hard to say what is the threshold of intelligence for something to be a robot. So this example, I think, highlighted some of the ambiguities in our definition, but I think it also showed how there are some strengths to this definition and the way that it interlocks and eliminates some things that we don't think of as being a robot. But it also highlights the fact that there is a real ambiguity between something that is maybe a device that does something with some sort of feedback control system in it and a robot. It's really becomes challenging to differentiate between the two. So those are a couple of things to keep in mind. All right, so that is our example, and we'll explore the meaning of each of these qualities of a robot in the following lectures. For now, let's pause a moment to consider the why of robotics. So we've now considered kind of what robotics is, or what a robot is, robotics being the study of robots. And now we want to talk about why robots. Why do we make robots? Okay, reasons include robots are cool. Okay, one motivating factor seems to be the awe we experience when creating something that appears lifelike. In fact, creating artificial life has been one of the explicit goals of some roboticists. Other roboticists have been inspired by biological life to create more effective robots. This field is called biomimicry. Very popular. You'll see robots that swim like fish, and robots that jump like a grasshopper, for instance. Second reason, biology is cool. A related reason to to robot as a verb, is that while we're creating artificial life and biomimetic robots, we frequently reverse engineer biological life, which yields a deeper grokking of biology. We can develop robots in service of biology. So studying biology is fun. Making robots that do things like biology can help us study it. Robots help make things we like. So robots help manufacture cars, airplanes, food, computers, cell phones, and many other things we like. So sometimes we like robots because of the things that they will help us make. Robots do dangerous work. Instead of humans doing certain dangerous work, like cleaning up a toxic chemical spill, robots can take our places, which is very, very nice. Robots can do boring work, especially in manufacturing, but also in household chores. Robots can replace humans in work that is repetitive and boring. This has the potential to free up human time for activity we find more meaningful. Robots can do precise work. Robot-assisted surgery, for instance, allows us or a human surgeon to guide a robot through a delicate procedure that requires mechanical precision beyond that of human capability. Also, we like money. Robots give us economic advantages, which give us money. Under our estrangement in capitalism, we fetishize money, not for its exchange value, but for itself. Sometimes we're motivated not for what we can get with our money, but also for the money itself. We must address something here. Despite its advantages, does not robot labor necessarily lead to the loss of human jobs and further concentration of wealth? Okay, so those are two things that do happen with the greater autonomy that robots get. So yes and no are my two answers. Yes, robot labor has in fact reduced human jobs and concentrated wealth, and it will continue to do so under the current world economic system, or capitalism. No, this loss of human jobs is not necessary. Under a different economic system, robot labor could have a positive impact on human being. So these are big topics and things that warrant detailed study. We don't have time to go into all of the details, of course, of that here, but it's worth thinking about. What is the impact of the type of technology that we're creating, and do we like that impact on human being? So great. Robotics, robots, it's what they are. It's why we make them. Maybe there are other reasons. There's just a few that I thought were worth mentioning. And also thought it'd be worth mentioning the sort of economics and how that plays in. So, all right, this lecture is now concluded, and we'll move on to the next one. Bye-bye.